Yeah, 1 and 1 is 2, and 2 is 2 is 4. 3 and 3 is 6, so now let's try some more. 4 and 4 is 8, and 5 and 5 is 10. 6 and...
Hey math lovers, let's go over this Chapter 3 test taken on February 25th, 2022. Determine whether each is an experiment. I'll just call this E, survey or observational study. Remember, an experiment is you do something to two groups, and you're going to compare those two groups. An observational study is you just watch, and a sample survey you kind of give something, you randomize them, but you don't compare it to two groups. So a biologist studied 5 insect burrows and took notes on their burrow size, insect population, and their activity. So what are they actually doing here? Are they doing anything? They're studying them, they're just taking notes, they're just watching. So this would be an observational. Make this super thick. O for observational. In order to find the average age of users of a park, a researcher randomly selected 10 people leaving the park. Okay, so here I'm just kind of like surveying people. So this would be an S. This is not an experiment because I'm not comparing two groups. A pharmaceutical company performed a study to determine the impact of a new allergy medication. 30 participants were given the new medicine and 30 participants were given a placebo. Then there are two groups, and their reactions to each treatment was measured. So you see the two groups. Here's the first group, and this is the second group of 30. So this would be an experiment. In order to find the average commute of workers at a company, a researcher randomly selected 100 employees at lunchtime and asked them how long it takes them to get to work. Again, if you think about this, although you're randomly selecting in your survey 100 in probably a big company, you're only looking at the people that are just going to give you a number. You're not giving like two groups. So this one would be a survey. I think those were 0.5 each. Question number 2, which of these is a statistical question? A statistical question should give you a quantitative, which is basically a number, and the main point of this is that your data will vary. Question number, what color are the eyes of students in the middle school? Are you going to get varying different types of answers? Yes, you are. And it can also be, forgot to throw that in, it can also be qualitative, but the idea is that it varies. So A is acceptable. B, how many minutes does it take you to get ready for school? This one is also a good statistical question. Actually, A. C, how many students in the 6th grade have pets? So you're just going to get an answer for this one, and your answers will not vary. And D, what kinds of pets do students in 6th period have? So you're going to get different types of pets on this one. Okay, I realize in B, it has a key word here. How long does it take me to get ready? And that just might be like, hey, 19 minutes. And that's just, you might say over a couple of days, but it just takes, they're probably just asking for one day. So it would just be A and D as your answer. Question number 3, we need to classify scenarios mentioned in the first column as biased. So bias just means it's going to help you lean towards one of the answers, or random samples, kind of like it's going to be fair, right? So Sam asked 15 of his friends what they thought about the pizza they just had. Well, of course, the friends hopefully are going to say nice things, assuming maybe Sam bought the pizza, but this is kind of biased. Because, you're in front of Sam, you're kind of fearful what he's going to say, so you better say you like it. Dorothy surveyed the first 20 people to a new website. Well, if you're the first person to find the website, most likely you're kind of looking for it, so you'll already kind of like it. Does that make sense? That's why it's biased. Chris threw some identical shaped marbles, then collected 15 marbles from the carpet. Well, it is random and it's fair, so this one would be a random sample. Question number 4. A retail company has 50 large stores located in different areas throughout a state. A researcher for the company believes that the employee job satisfaction varies greatly from store to store. Which of the following sampling methods is most appropriate to estimate the proportion? I'll highlight this one. Proportion of all employees who are satisfied with their job. So the proportion just means sum overall, and the company is so big that they can't interview everybody or get their opinions, so they're just going to do sum. So how can we do that? A, selecting one of the 50 stores at random and then surveying each employee at the store. Question, would the whole store be representative of the 50 stores? I would say no. They might be super happy, they might be super upset. B, selecting 10 employees from each store at random and then surveying each employee selected. I like this because every store is being represented. So I like this one. C, surveying the 25 highest paid employees and the 25 lowest paid employees. I think the highest people are going to be happy, and the 25 lowest are probably not going to be. They'll be a little bit more critical. So I don't think that's a good representation. D, creating a website in which employees can express their opinions and using the first 50 responses. Well, the first 50 are probably, again, they're going to extremes. They're either super happy or super sad. So I don't think that's a good representation. So I would say B is our answer. Number 5, William has a 3-point shooting average of 80%. That is amazing. He wants to determine the number of points he can expect to score if he takes 5 shots, which describes one trial of simulation for this situation. So the simulation basically means hey, I want to know what William does over 1,000 shots. Well, the point is that he's making 80%. 80% is 80 over 100, or you can reduce that to 8 out of 10. Does that make sense? So basically this is something we want, or 4 out of 5. You just divide them by 2 there. And so I kind of want a number that kind of represents something like this, okay? A, write the numbers 1 to 8 on note cards and see how many times the numbers 3, 4, and 5 are picked. Or 3 and 5. So this would be 2 out of 8 numbers, and this would only give me 25%. So that would be a big no. B, generate 5 random integers from 1 to 10 and see how many times the numbers 1 through 8 are generated. So 1 through 8 are makes, and then 9 and 10 are misses. So if you're picking the 8 makes, this would be 8 out of 10. And that would match what we have here. So this one meets our needs. C, throw a dart at the dartboard and see how many times you can score 80 points. In a dartboard, there's different sizes, right? And more points accumulated, but it doesn't necessarily reflect an 80% accuracy. And the last one, generate 3 random integers from 1 to 10 and see how many times the numbers 1 through 8 are generated. What's the difference between this one? Okay, so this one has 5, which doesn't matter. And this one has 3. Oh, I do see. So they're exactly the same, but the 3, he wants to know how many out of 5 shots. So it should have been 5 shots, which I have here, not 3. So our correct answer is going to be B. All right, question number 6 says, a high school randomly selected 75 of the 200. So remember, the big idea for statistics is I'm not going to interview all 200. I'm just going to do 75. 75 is my sample size. The mean grade point average, or GPA, of the seniors selected was 2.85. So if I ever need that information, it would be kind of like an X bar. And the standard deviation is 0.4. So I'm going to put that 0.4 down here because I'm using that in my formula. Select all that, apply. So margin of error, it tells us the formula kind of nicely, is 2 times 0.4 over the square root of 75. So let's put that in our calculators. 0.2 times 4, because that was in the numerator, divided by the square root of 75. You have to press the right arrow to get out. And I get 0.092. 0.092. So B would be my answer. And then look at C and D. It talks about what would happen to the margin of error. The margin of error would decrease if the sample size was changed to 125. So you're going from 75 to 125. So what happens when you get more and more people? It's going to be more accurate, and the margin of error would actually decrease. So your answer would be C here. Question number 7. In a survey based on a random sample of high school seniors, high school? Random height sample of high school seniors. I don't know. 70% surveyed said they do more than 3 hours of homework per day. Based on the data, the following conclusions will happen. Can they get exactly 70%? That's really hard to get. It's always going to vary, right? I sample 50 over here, 50 over here. About, I like this word better, about. Exactly 30% of all seniors at Whitney do less than 30 hours. No, that's not the case, because maybe 80% do less than 3 hours, but it's going to be around 30%. So don't do any complement or subtracting here. The answer is going to be B. And question number 8, a completely randomized design for an experiment includes. So if you remember back in your notes, the first thing you kind of want to do is have how do you pick your experimental units? Well, your experimental units should have some kind of chance process or random. So chance process is the first one I would do, right? And then I want to give them some kind of variables in how I selected these people, keeping as many other variables as possible same for the group. So this would be my second choice. Because, let's just say I want to test. I was just watching a video this morning, and they're saying maybe now they want to give the COVID vaccine to males between ages 12 and 39, and they want to do this with a longer waiting period. But they're picking just males and that age group. Does that make sense? Okay, now with those males, you're going to impose treatments. So I'm going to give, this is step 3. So maybe I give the video set 8 weeks for those males, and maybe compare it to the 3 weeks that have been traditional. And what they were concerned about is that they might get some kind of heart issues. And then the last one is you need to compare the results. And then they probably found that those who took 8 weeks between the vaccines had less chance of getting some heart disease. Okay? Hopefully that was helpful for you guys. We'll see you guys later. Bye.
Thou shalt not covet thy neighbor's paper, nor anything that he has. I love man.